Okay, chapter 8. This is a lot of this is systems. So I'm going to do a lot of this in the calculator because I feel like most of the questions on the EOC are actually going to be that pertain to systems will be on the calculator portion. So try to make this easy for you. So let's look at number 1, right? Consider the following. F of x equals 6x plus 2 and f of x equals 3x plus 2. Which of the following statements is true concerning the graphs of these equations? Now, I'm just going to talk you through this. So, well, I guess I should probably write some of this down so I don't lose you. So look at equations that are set up as y equals mx plus b, which is exactly what we have here in number 1. We have y equals mx plus b, or f of x equals mx plus b. M is always the slope, and b is always the y-intercept. So if you think about a graph, parallel lines have the same slope, right? So if I have one line that is y equals, let's say, 2x minus 4, and the other line is y equals 2x plus 3, these would be parallel because they have the exact same slope. They're both going the same direction, up 2. But they have different y-intercepts. One's at positive 3, the other's at negative 4. But they'd be parallel lines. Also, let's see, something else to consider. If they have different slopes, period, so y equals 2x plus 3 versus y equals 4x plus 3. If they have different slopes, they're going to meet at one point. Doesn't matter what their y-intercepts are. They can be the same or whatever, but if they have different slopes, they have to have one point of intersection somewhere. So be aware of that as well. Same slope means they'll be parallel, though. So notice in number 1 that you do not have the same slope, so they're not going to be parallel. If you want to, you can graph those lines by going to your calculator and going to your y equals and just physically plotting them on the graph. Let me clear that. But when you do that, make sure that your window is set to a normal window range. So that would mean x min would be negative 10, y min would be positive 10, and the scale would be 1, or I'm sorry, x min and x max, negative 10, positive 10. Then the y min would be negative 10, the y max would be positive 10, and the y scale would be 1. That's your normal window. So if you want to type in your graph, you can hit graph and then view it, and you'll be able to kind of hopefully answer that question from that graph if you really need to. All right, let's talk about number 2. Number 2, what is the solution to the system of equations? So again, I think you're better off just plugging those straight into the y equals, graphing them, and seeing where they cross. So I'm going to put up a different example just to kind of show you what to look for. So let's say I've got 3x plus 2, and let's say I have x. I kind of want one that works. So maybe this, I don't know if this will work, but we'll see. I might change it. But let's say those are my 2 lines, and I can graph it, and I can kind of see where they cross. That doesn't look as good as I wanted it to. Hold on, let me choose a different one. I don't want a fraction as an answer. That's what I'm trying to avoid right now. So just sort of trying to make it up so it's not a fraction. Okay, I think that looks good. All right, so I can kind of tell, it looks like it's crossing at about 1, 5, right? But it's kind of hard to tell in the graph. So if you wanted to, you can go to second graph and look at the table. And on the table, you're looking for where both y values are the same. So you see here, they're both 2 and 4. They're not the same. But here, they're both 5. And that's at x equal to 1. So they're both points 1, 5. 1, 5 there and 1, 5 there. So they cross at the point 1, 5. They don't match here. They don't match anywhere else, right? 11 and 7, 14 and 8. Oops, it's gone now. But you're looking for where both of them were the same, and they're both 5 at 1. So that was the point 1, 5. So that's what you can do on number 2. Number 3 is already graphed for you. You're just kind of making, I guess, figuring out what the equations are. So my best recommendation there would be look at the slope of those lines and the y-intercepts and just match them with the ones below. Now, you got to be careful about b, though. answer choice B is not in slope-intercept form, so I would put that in slope-intercept form first. Everything else looks to be in slope-intercept form. And just try to see which ones have the correct slopes and y-intercepts. I know that one of the lines, it goes through 0 as a y-intercept, and the other one goes through 2. So I would look at my answer choices and see if I had any like that. And then I would also look at the slope. One's a negative slope. The negative slope is the one that goes through 0. And the positive sloped line is the one that goes through 2. So I'm going to look for all those things and then try to come up with a conclusion. So definitely look at the slope and the y-intercept, though. So number 4 says which of the equations below is parallel. So my advice for number 4, you're going to have to do this no matter what, whether you like it or not, with a calculator or not calculator. You're going to have to take each equation. So look at answer choice A, right? A has x plus 3y equal to 3, and 3x plus y equal to 3. I'm not going to work out all of these, but I'll just tell you what you need to do. You have to convert every single one of these answer choices into slope-intercept form. So take example, this first one, right? You have to set it up in mx plus b form. So that would mean subtracting the x on both sides. So you'd have 3y equal to negative x plus 3. And then divide by that 3 so you can get the y by itself. So the y would equal negative 1/3 x, because that's negative 1x, right? And divided by 3 is negative 1/3. And then plus 3 over 3. 3 over 3 is 1. So that would be the slope-intercept version of that. You're going to have to do that for every single one of those. And then because it says parallel, you're going to look for when both have the same slope. So if the other equation here in A, if the 3x plus y equals 3, if that has the exact same slope as this, then the answer choice would be A. But if it's not the same slope, then you got to move on. So you're looking to see, of course, put them in slope-intercept form, and then look for the pair that have the same slope. Number 5, which order pair solutions to the following system of equations? This is, because it's multiple choice, you could actually just plug in the x and the y's. So like, for example, you can plug in negative 13 for x and negative 2 for y in both equations and see if it fits. If it doesn't fit, then you could try a different one. But what I would encourage you to do is, if you want to be easier, you can try to set it up in slope-intercept form and graph it again. But this problem is set up best to be done with the elimination method. So let me make up a different example that's similar to it, but not the same. So let's say I have negative 5x plus 8y equal to, I'm just going to make it up, 23. And then let's say I've got 5x plus 5y equal to 14. This is probably going to be a terrible answer, but at least I'll show you the process. So I notice if I'm using the elimination method, I just add the x and y's and stuff together, but with the intention of canceling them out. Now, in my problem here, and also in your problem, I have a negative 5x and a positive 5x. This right here is primed to cancel out, because negative 5x plus 5x is just going to be 0x and disappear. So when I add them together, I get 0x, which is great, because then it's eliminated. It's not there. As far as the y's go, I've got 8y plus 5y, which would make this 13y. And then on the other side, I've got 23 plus 14. 23 plus 14 would be 37. So actually, let me make this easy. Let's make that 16. 23 plus 16, so this would be 39. Now it's going to be a nice answer. So dividing by 13 on both sides, that would mean y equals 3 here. So y equals 3 is already part of my answer, so I would look to see if I have that in any of my answer choices. And then also, if you want to find the x value, if you have the y value, but you need to find the x, then plug this y in to either function. Plug the y in here or here. So you can say, if you put in the first function, it'd be negative 5x plus 8 times 3 equals 23. And that would, of course, be negative 5x plus 24 equals 23. And then you could just try to solve this. So you can plug that y in to find the x, but the elimination method would work great on number 5. The elimination method would also work good on number 6 as well. So that's just some advice for you. Number 7. Yeah, okay, I'm just making sure I'm on the right page here. Number 7, you've got a word problem, but it's basically the same. You just have to write the system out first. So let me use a slightly different version of this. So let's say it was $2 for children. I'm going to make up a different example. So $2 for children, and let's say it was $5 for adults. Right? And one day I had, let's say, 3,000 people show up. And also, let's say I had, as far as money was collected, let's say I had $4,500 collected. $4,500 collected. So it's similar information that you have. So how I would write this out is I would have $2 per child plus $5 per adult. And this is all about dollars, right? $2 per child, $5 for adults. And that would end up being the total that I got, which is $4,500. So you have an equation here, and this equation is strictly about dollars. $2 per child, $5 per adult for the total amount that you made. And then the other equation would be about the number of people. So you'd have some number of children plus some number of adults to be a total of 3,000 people. So there's no number associated with this, like as a coefficient. It's just however many children plus however many adults went ended up being 3,000 people. And so now you've got this system of equations that you would go and solve. I'm going to try and find my old system video that works out a lot of problems similar to this and attach it to the description of this video so you can go watch it if you want to see how I would use the elimination method on this problem, because it's been a while since we did the elimination method, but that's what I would do on this. Okay, two numbers. Number 8, two numbers that have a sum of 210 and a difference of 30. What are the two numbers? That's more or less a kind of a riddle. I think you can figure that out. There's two numbers that add up. So some number, if you want to write this out as a system, it'd be some number, we'll call it x, plus another number y. They add up to make 210. But then they say that the difference is 30. So you can say that x minus y would equal 30. I would think. Yeah. And then you can solve that system of equations, which again, I'd probably use the elimination method for. I would definitely use the elimination method for. As far as number 9 goes, number 9 is definitely one that you want to type in the calculator and look to see where they cross. So they're going to cross at 2 points. So you want to get the x values where they cross. That is going to be as straightforward as it gets. Just go to your y equals, type in both equations. I'm not going to type them in for you. I think you can handle that. But type in both equations. Make sure your graph window is set to normal, and then graph your equations. And then look to see where they cross. It's easy as that. Number 10 is the same way. Number 11 is the same way. Number 11 is a little more of a decimal, but you can still get there. Number 12 is the same way as well. So that's going to be it. That covers basically everything for chapter 8. Like I said, I'll put a link in the description for the old system notes so that you can go back and watch the substitution method, elimination method, all that stuff again, because it can really, really help. All right. I'll see you guys next time. I'll see you in chapter 9. Bye.